Okay, thank you, Guy, for letting me talk a bit about the work we've been doing on step standards for manufacturing and letting me be at this conference. I've learned a lot about what's going on over here. I think it's very generous of you to allow me to be here. So my name is Mark Hardwick. I'm a professor of computer science at a small technical university called Rensselaer Polytechnic. It's in upstate New York, about 100 miles north of New York City, close to General Electric's research lab, kind of near all the IBM plants are below us and that sort of thing. We have very strong research programs in the semantic web and social networks. And I've been working myself in product modeling for many years now. So I'm leading a team that calls ourselves Spec Manufacturing. It's a subcommittee of ISO. The team consists mostly of aerospace manufacturing companies, but not exclusively. Scania is not actually aerospace, it's heavy equipment. But these are all big users of manufacturing systems. There's also equipment vendors in there, particularly cutting tool vendors, and to a lesser extent, in the past quite a bit more, Mr. Toyo, the metrology vendor, and experts like NIST and KTH in Sweden, Ameritex, essentially a small consulting outfit. Step Tools is a company that I formed with my students out of some work we did for DARPA a number of years ago, and Rensselaer is also in there since I'm there. What are we trying to do? Essentially, we are trying to create manufacturing models. We want to create those models so that people can get help. So if you have some kind of problem, you can send a model of that problem to some kind of solution service provider, and then they can go ahead and send you a model of a solution that you can then go ahead and use on the shop floor somehow. And I'll talk about a couple of pilots we have for that style of work in the moment. One of the barriers that we've been trying to wrestle with as we try to achieve this way of doing things, certainly the biggest initial barrier is the complexity of the models. You need to be able to model the geometry and the tolerances and the assemblies and the features and the processes and the machines and the fixtures, and there is just a lot of information to model in manufacturing. So it's taken a long time, 20 years you might say, to go ahead and assemble enough modeling elements to be able to do that. Not only is it the problem, but also the solution needs to somehow be described in a way that you can go ahead and deliver it back and have it be used on the job shop. So we have our step model, step AP238 and step AP242. 242 for essentially describing the problem, and 238 for describing the solution. It's not good enough, of course, to just have the models. You've also got to have systems that can read and write those models. It has to be put into a form that the people in the shop, the people providing the service, can make sense of it and do things with it. So certainly you need libraries to help the implementation, and that's where Step Tools come into things, but also other kinds of companies, competitive companies are also developing libraries. So there's a market out there for those libraries. And then the commitment by the CAM vendors to go ahead and implement those translators. And we do now have a commitment from 3 vendors, Mastercam, Siemens, NX, and the Soviet. to go ahead and put in interfaces to read and write the 242 and 238 data. And then the concept is great, but you actually have to have real services that go ahead and do real things of value. So this is where we're currently working, and we've come up with a fairly strong one in CAM tooling that's going ahead. I'll talk a bit more about that. We've also got a stronger concept for the made-to-measure kind of service, but that's probably got a 3-year horizon on it. And then a global kind of manufacturing simulation sort of service. That's where I find this particular meeting to be very interesting, because it's the 2020 kind of goal, and what could we put together based on what we've got and what's coming together to try and meet that sort of thing. So the CAM tooling, which is the most concrete one, will be meeting to have a kickoff in 2 weeks' time in Virginia on this one. Basically, the idea is that somebody, say an aerospace vendor or a new user, would go ahead and design a program in a CAM system. Save it out as a step-in-C file, which would then go to the tool vendor, who, let's say it's ISCAR. They've souped up their CAM system so that when it receives these models, it analyzes the models in great detail, figures out, well, that's the automation they describe, this is one of our best tools for that kind of thing, what sort of quantity they want to go ahead and make things in, what's their sheer constraint, they're trying to minimize time or minimize cost or whatever else. But the basic idea is that they make a recommendation. So they save it as a step-in-C file with optimal process and the tooling recommendations embedded in it. It then goes back to the job shop, and our end users are comfortable with thinking that they'll get a 15% improvement at least out of this. And also, it will make machining easier and safer for new entrants, since whatever they created in that job shop can, imagine it was a high school student, saved it out, sent it this kind of service, and they would make sure that the speeds and feeds and process were safe for the equipment being used. So again, that would be a benefit of this. Another nice thing about this sort of service is you can see that providing everything works technically well, the tool vendor is going to want to do this as a service for his customers, because the customers then going to go ahead and purchase those tools. So everybody is kind of winning here. The job shop's getting free advice and free improvement. The cutting tool vendors getting opportunity to sell better tools that then get deployed and used in practice, because they can show people how to use them. The made-to-measure, this one is less well defined, but basically is operating on the same sort of principle that you're going to go ahead and have CAM programs, this time for making the panels that fit onto some kind of structure. So you go ahead and save those with the as-planned panel profiles in there as a step-in-C file, then goes to the metrology system that is measuring the as-is flexible structure, which varies slightly just because of the fact that it's flexible and big, and it just does. So you measure the assembly contour, then you've got a corrected profile that can go back into the step-in-C file, which can then be used to make that panel just ever slightly bit more accurately for assembly onto the airframe or ship or building or whatever else there is. So this one is also sort of being scoped out. This one, I think, is not going to be done by vendors this year like the previous one is. Instead, we're going to be running a pilot or test at some facility. Probably closer to actually buying this because it brings everything together with 242 and 238 and the tolerances and the metrology and the cutting and everything else into one framework. So we'll probably pilot that in 2014. So those are those two pilots. Where are we going with the STEP standards in the next 5 years or so? Here's something which may be controversial, maybe not, I don't know. But we think within 5 years it's time to get rid of G-codes. But that's a kind of nutty way of programming machine tools, particularly when you think about the next generation. They're not going to really want to talk about at that level. Who really would? Languages like JavaScript are out there. They're perfectly elegant languages. They can be used to express what you need to do in the algorithms. And it's time to go ahead and start thinking about doing some kind of replacement. And I heard comments yesterday about how when the idea of putting Windows on a CNC was considered to be not on. I think people are going to have initially the same kind of reaction to this, but I just can't see why we carry on using those G codes. All these manufacturing services, assuming the idea works, that ought to start aggregating up into databases where people will start declaring what it is they can do. And you can go in and search and marry your process up to equipment in some kind of advanced sort of search engine sort of way. Again, if we come up with agreed standards for how the information is going to be represented, then we can come up with algorithms and search engines and tools to dig in there and start doing reasoning. It's a question of agreeing on something and getting the information base out there. And last but not least, I think it's time that we all started thinking in terms of voxels. Voxel being the three-dimensional equivalent of a pixel. Obviously, the problem with voxels is that you very quickly get far too many of them. Millions and billions, but we're getting enormous amounts of storage together. Just because you are going to be doing the things on the voxel level doesn't mean that you have to store everything that way. You can come up with lots of clever algorithms to do it contingently in different areas or different focuses. But it's a way of simplifying everything. The voxel exists in a particular space. The processes are laying things down on removing things from that particular space. If we all are working at that level, things could become much more synergistic. So the specific thing that we've done already is Part 21 Edition 3. This is a draft international standard. It does two things. It supports the creation of massive product models. Those of you who have used step files or seen a step file probably recalled in horror, but then B, realized it was one file for describing the product. Now there's going to be URLs and URIs to link those files together. So it's updating it for that kind of technology. And then also beginning to get some crowdsourcing intelligence in there. Do these files have to carry on being dumb flat files that can't do anything except wait for an application program to come along? We can embed behavior in there and start getting some object-orientated, method-orientated, intelligent-orientatedness in them so that you can start doing things without having to have a CAD system all the time. Today, whenever you're doing them with a step file, you've got to read it with a CAD system first and then you can do some manipulation. And the last goal with Part 21 Edition 3 is to make it upward and downward compatible with the previous editions. We don't want to lose that legacy, we want to carry on supporting it. So this particular file illustrates the basic notion. The data section existed before, the header section existed before. There's just two new things in there called the anchor section and the reference section. The anchor section declares the hooks that you can link to from the outside. So there's 3 hooks there: tooltip face, tooltip usage, and tooltip unused. Tooltip unused showing that in this particular iteration of this file, there is no anchor value for that. But otherwise, it's telling you where to go to in the file, in the data section, and then they're both going to the same particular entity in this very simple small example. And then references for output bound links. So I've got a reference to a bottom face in some other item and a bottom face representation in some other item, which are actually used in that one data entity instance I've got left in the file. So now I can go ahead and link these files together and have them distributed over the internet, etc. Or I could start putting them into zip archives, and that's something that is also going to be supported in this extension, so that you can think of one way that the new step file will work is what was one previous monolithic file will now be a zip of multiple small files, each of which may describe one component, and intelligent applications can now go ahead and just work on sub-pieces, don't have to work on the whole thing. And there is a directory in the zip that basically leads off to where all the little pieces are. This particular directory is going off to the sub-components inside it, which are all individual step files linked together in an assembly, which is then has got a set of tolerances on top of it. One of the reasons for doing this is to start to become more inclusive. There's always been criticism of STEP that it's either my way or the highway, but with the ability to have the multi-file HTTP links in there, we can now have other files like, say, a JT or an XML file referenced into our anchors, and we can also have our files reference out to other types of data. So a JT file, for instance, or if we're doing Step NC AP238, we may want to reference out to a work plan that's in the 14649 format, particularly when that fits that particular style of NC program. That again is supported within the new framework. And again, I'm talking about a 5-year horizon here. This is not all going to come together immediately. This is an example of the JavaScript kind of thing. Just a simple program. This particular program is making the work plan object more intelligent. Work plans need to be associated with a work piece that describes the as-is and to-be models, so the work plan object would know how to connect to a workpiece object within this particular framework. We have quite a bit of JavaScript experience in the step tools because of the work we've been doing now with the DARPA Advanced Vehicle Make program. So we have a website full of JavaScript, WebGL kinds of demonstrations showing this technology kind of coming together. WebGL is also becoming rapidly more popular. It was an issue that Microsoft was not supporting yet. They're still not supporting it in their mainline product, but they've more or less announced they're going to go ahead and support it. And Google is using it for the Street View stuff. So, just to sort of give you a flavour of where things may or may not be coming from, I am unfortunately old enough to have been around when the internet first got deployed. I remember those good old days. There were many networks that folded down when I was a student to more or less 3 networks. There was IBM Net, there was DECnet, and Domain Net, which was used by those Apollo workstations and had some kind of token ring thingy going on. And those all folded down onto the internet. Though I have vivid memories of going to CMU while working on a virtual enterprise program with the IBM program manager, who basically said, well, you can use that internet thing if you have to, but the IBM tends to build network. Why did that all change? It changed because the internet was a comprehensive framework that would allow you to do your IBM net on top of the internet or your DECnet on top of the internet. It didn't try to exclude you. It allowed those things to continue, and of course there was also the whole killer app thing. Where killer app usually means something for nothing. So you've got the World Wide Web, which was, again, the same meeting. People were putting their resumes up on the web for the first time just because they could. It seemed like a silly thing to do, and we all were wondering how they were going to go ahead and find those resumes, but they were doing it, and they were linking their references one to the other, and it instantly sort of took off. So, where are we with the whole models for manufacturing, for design, for planning? We're actually in a fairly interesting state right now. If you go out to the businesses or business-oriented conference, they'll talk to you really about 3 choices. The 3D PDF, which has come along great guns in the last 3 or 4 years, used by the Army and all kinds of other folks. JT, which is now being made into an ISO standard. JT is the favourite of the European automotive companies, and is also being used heavily by the US auto companies, but the US auto companies are looking at 3D PDF in the same way we should be using swapping here, I'm not sure. And US Aerospace is making a great deal of 3D PDF, and we all ignore XBL, but that's a huge one out in the Far East. That's the Toyota, Honda standard for their product later. Each one of these is sort of semi-contingent. It's made more practical by doing some things more simply. But because it's simple, it's been easy to implement and it's got huge bases. So the real question is, do we get to fold that down to one product model framework that everybody goes ahead and jumps on board? Which one is it? And are we yet at the level where we're going to be comprehensive enough to trying with Part 21 Edition 3 to be more inclusive, to make the framework so that everybody can layer what they want to do on top of it, so that Step AP238 can start working with Step NC ISO 14649, and AP242 can work with several different business object models, that they're all within the framework that you can layer on top of it. Basically, the underlying step aim removes all ambiguity, and the business object model above that layer gives you something easier to implement because there's an assumed context that everybody can just go ahead and use, and you have to do less state definitions. And then the killer application, of course, has to be that you need something for nothing. The CAN tool service that we're providing is in some sense a little killer application because it is providing something for nothing. Free speed feed optimization followed by engagement, maybe followed by some features, but that's a small area within the total part of manufacturing. So that's not enough on its own, I think, to drag this thing forward. But if we can drag it through and drag something out there, we can then start seeing some really strong synergies. So that's really where I'm at with the work we've been doing on standards. Okay, question, yes.
I have a quick question actually. Derek Sigler, University of Warwick.
What's your strategy actually? Your last slide which you have shown actually is quite an interesting slide. You show quite a number of different applications actually. So your strategy is you are looking for this comprehensive enough solution or killer apps, or you are going from this blue 3PDF, JTs or XDL and so on. What's the strategy for approaching this issue here which you're presenting?
Well, the strategy is a twofold one. First of all, you've got to not exclude the other guys. So they can carry on doing 3D PDF within your framework. So that's one part of it. And the reason the question mark is we've done edition 3 that allows this linking and so as to serve up the data in different contexts. And it should also all be transparent. So that's the one half of the strategy. That creates an environment where no one is excluded, but you now need the pull. You need this application that attracts people to get on there and do it, just like the HTML did with the internet. A bunch of professors stuck their resumes essentially initially on there and linked it together, told other professors who then got really interested about linking in their references. It sort of spiraled.
One quick question, if I may. What's the best way to get engaged? Let's say, for example, one of the projects you are currently working on, Remote Laser Navigator, we have some models which potentially can be added. For example, you mentioned voxel 8. So we do not necessarily voxelization, but to some degree modeling the behavior or specific behavior of the components. So it's not a pure geometrical model, but it's a modeling, for example, behavior as it is happening during the assembly and so on process. What would be the best way, for example, to kind of engage or to have some more discussion or to understand a little better more details, for example, what you have it and everything.
That is an important point because the barrier to entry, the spec toolkits are quite expensive. They're meant to be used by CAD vendors, professional programmers. There needs to be an open library of objects that when we split the large step files up into the smaller modules, we then start working together to create the functionality, like the JavaScript a couple of ones earlier. And we all share that as open source. So that's kind of the strategy. And we've done a little bit of that, but it's not it's not much yet. My plan is to start getting some RPI students to write more functions in the fall, and hopefully it works out well enough that other people then start also writing functions.
Yes, I have a couple of questions. First of all, you earlier said something about the support of the vendors, but who do you mean by the vendors? You mean the CAD vendors? You mean
the two CAD vendors that matter to the large aerospace companies in the USA, the key guys, that's CATIA and Unigraphics. And to be precise about where we are, they have announced in public in several meetings that they're going to support AP238. But they have not followed through too much yet. They have export tools, they can write some data, and that's, we're now working on getting them to follow through on their commitments.
And then my second question is more to some other people here in the room and you, and probably starting a discussion. I have been all my career allergic to these words from artificial intelligence, like paradigm shift and ontologies. Now, yesterday there was quite some filling on ontologies. Now, where could you comment on, if you take your last slide and your green question marks in there, how does that fill, and how do these younger computer scientists who summarize all of this in ontologies, how do they define that? When you come to features, to all your descriptions from a manufacturing engineer's point of view, and they come from the other side with a very abstract, ontology is a concept out of philosophy, which basically says all-embracing. Now, can we make that a bit concrete, or could you comment on it? How far are they helping you with that bit? And just to say why I'm asking that question, which leads to my third question. We have really a very long history in also US IMS cooperation on step 184 SC4. I almost feel like at home 30 years ago. Now,
that reminded me that the same thing happened with the internet. It went on for years and years, but we got really sick of it. Finally broke out. But, yeah.
Okay, I have been out of it for such a long time that I'm no longer allergic. Okay. But the point is also that in research management, from my perspective, there is a huge debate going on what could be pilot lines. Now, what pilot lines are in microelectronics, we all know. It's a some sort of in between 2 billion and 8 billion fab somewhere built on 450 millimeters factories. That's today the understanding on pilot lines, and it comes all from there. And there is a whole framework out there to fund these kind of pilot lines in these overall reindustrialization strategies. Now, is this not exactly the topic for manufacturing, where we should pilot the handover of standard data files and show that it works, and that it works not only for the big aerospace manufacturers, that it works in between all people which are in your, what you call the supply chain, or whatever the word was on another slide. Is it not exactly that what should happen?
Yes.
Why don't we have that proposal? We had in previous framework programs exactly the right people who would build that kind of proposals. By the way, in the original project here was already an interface which led to the STEP standard. There was already an interface definition on knowledge-based interfaces for CAD systems. It was probably subgroup 7, and the other ones were much more concrete, but this one already was there. I remember that very well, that I always thought, oh no, and here they go again. And it's...
Okay, partly what's going on here is there's been a breakthrough in the modularization of Part 21 and E3, putting the URLs in it. It's an obvious idea. We can all kick ourselves for not having thought of it before. I was sort of myself in my own research in almost 10 years of stasis, not knowing where to go. We had these huge files which are just becoming too unmanageable. Now that we've split them up, we are becoming more inclusive. To get to your ontology remarks, with these models out there, we can build ontologies of what kind of properties that particular model instance fulfills, so we can have an interface, a more synergy between the two communities over that. So I guess the STEM idea was a great one, but hit a brick wall around about 2000 because of the monolithic nature of the technology for implementation. And now, with it going more modular, we've opened up, I believe we've opened up, because obviously I haven't shown it, I don't know PowerPoint, but it is opened up again.
Sorry, I won't take too long. I'm sure we're running out of time. Sanjay Mann, University of Hardwick. Thanks for your presentation. I was interested in terms of machine tool programming and why you chose JavaScript and what are the particular benefits of JavaScript for that sort of programming.
The main benefit of picking JavaScript, I would say something like Python or Perl. It needs to be one of the more productive, less fussy programming languages. You just want to describe what you need to describe and not get into all those C++ kind of bits and bobs and words and things. So it needs to be one of the higher level languages. The main benefit of JavaScript is that it's clean. It's not a security risk. At least as far as the mathematics is concerned. And a large number of enterprises will allow JavaScript to execute within their browsers because it can't create any side effects, which is what Perl and Python can do. They're pretty good at doing those other things. And there is actually an interesting point there, given at least historically, we manufacturing have been pretty kind of slow in getting technologies done. It could be that by the time this all goes through the system, the computer scientists will have yet another even better language that we will choose to use. But JavaScript seems like it's a choice right now.
Just if you want one short comment on this issue about ontologies, I think this kind of standards, I think that ontologies or semantic technologies will be used and will be useful for this semantic interoperability level to talk the understand the same model, etc. I think if you go to numbers, to the real files where you cut measures, etc., we will have need of technical exchanges, which will be of this kind of files. So ontologies will not go to, I think, to the level of the very machine details. To some concepts, yes, but when you need to go from one point to the other, you will need some language that tells the cutting tool to go from here to there. You don't need ontologies there.
I would agree that the models describe the product and process, and the ontologies help you find the model you want.
And why don't we get those proposals?
They're coming.
But I mean, my point is even more. If we get those proposals, they are designed as if you have never attended an evaluation. I want to warn you. Don't make such a proposal. You know the nice English expression, Irish need not apply? It means, for the English mother tongues, they understand the term, but it means without major users, without some understanding how the vendors are involved, the vendors you were mentioning. Without a clear standardization strategy towards STEP and ISO worldwide. Don't even do it. But if you do it like that, it is the logical project to do right across European and also international lines, what Rolf was explaining and Denver were explaining. And I really don't understand why these kind of things we have done, and they have been extremely successful also for some standards which are long forgotten, but one of them is STEP. And why don't we do it today?
For me, there are two different reasons. Market reasons, so the vendors think one thing is cheaper, and the other is competitive. So this is my own explanation.
I don't want to further comment the issue of standardization, but I want to address a different point of view. As you mentioned yesterday, the next step for machine tool vendors would be to integrate CAM support on the machine level, which goes quite in line with the idea of the German Cyber Physical Systems program, where you want to put more intelligence to the machine. So, and at the first place, you put more intelligence to the machine, that's nice, but the second issue you have to define what sort of intelligence and what the interface will be changing. So the initialization will have a complete different dimension between the power distribution between the designer and the manufacturer, or between an OEM like Airbus and the supplier. And I think that could give some more momentum also to the issue how to spread the standard and how to get the support on a broader basis.